Hello, awesome Mindsetters. This is your favorite show, Learn Extra Live, with me, AB Abram, and we are having our Triple M dates back. It is our Mindsetters Maths Monday with Natasha. How are you, Natasha?
I'm very well, thanks, Abram. Thank you for asking, and it's good to see you back on a Monday.
Happy Women's Month.
Thank you, thank you.
I hope you also enjoyed your Women's Day.
I did, and it wasn't a good restful day, but it was still good.
It was a long weekend, though. I hope it was long enough for you to rest.
No, absolutely not. I think our long weekends should be much longer.
Oh, I'll ask the Mindsetters about that, because to me, I felt like, you know what, it is just too much. I need to come back to work and do what I love. But otherwise, what are we doing today?
All right, well, grade 10s, today we're looking at statistics. Specifically, we're going to cover measures of central tendency, and we're also going to look at measures of dispersion.
I like that. Now, let me tell you, Mindsetters, we have 4 exciting things that you need to know. One is that you can chat with me over Facebook. Our Facebook page is facebook.com/LearnExtra. Like the page. We're currently having about 49,954 likes. So join us and be that 66 for us to have 50,000. And if you don't know about anything, what Mindset has to do, go over Facebook. We'll tell you what's happening even during the show. If you have any questions, feel free to go over Facebook, like us, and if you have liked us, comment and help other Mindsetters. Secondly, you can join us on Twitter, follow us at LearnExtra, and then thirdly, you can download your notes for today's show just for free on learnextra.co.za/live. And the last thing that you need to do, we are on Curio, whereby you can visit Curio on curio.co.za or via your Mixit, and then your code for today's show is M10. Take the assessment and let's see if you understand anything, because at the end, Natasha will be helping you on some of the questions that are on Curio that are giving you some troubles. But for now, enough about talking. Natasha, take it away.
All right, thank you, Abram. All right, guys, so as I said in the beginning, we're looking at measures of central tendency, and we're looking at measures of dispersion within statistics. Like Abram was mentioning about the Curio question, one of those questions we will be looking at in today's lesson. So if you have any problems, obviously you can follow through with us during the lesson and let us know where you struggled and where you still need a little bit more help. Okay, so first we're going to go over the definition of what is a measure of central tendency. I'm sure that most of you would have come across this term by now doing statistics in grade 10. So what is a measure of central tendency? Well, basically, it just tells you what a typical value in a set of data is going to be. Okay, so let's formalize our definition. A measure of central tendency is a value that represents a typical item in a set of data. All right, we have different measures of central tendency. The first one we'll look at is a mean. And a mean, another word we use for mean is average. Okay, your mean or your average is equal to the sum of all the values in the data set divided by the total number of values. We also represent the mean as x bar. Okay, so you'll also see it being represented like that. And we say it's the sum of all the values in the data set divided by the total number of items. So you might come across the mean written in this way, and that's basically what it means. We're taking the sum of all the values, dividing by the total number of values. Okay, so that's the first measure of central tendency. The next one we're going to look at is the median. We also represent the median with the letter M, capital M. And the median is basically the middle value of a data set. So it's the number that's exactly midway. So if I had to sort of draw a picture for you, it's the one that's exactly midway between your set of data. Okay, but in order for you to work out the mean, you need to have an ordered data set. If there's an even number of values, okay, so if you have, for example, say you have 12 values in this data set, then your median is going to be in the middle of the middle 2 numbers. So what that means is if you've got 12 numbers in your data set, obviously a half of 12 is 6. Okay? But when you order your data, you're not going to be able to get 6 numbers on one side and 6 numbers on the other side. You're going to have 2 central values. So what you would do is you take those 2 numbers, you add them together and divide by 2 to give you your median. But we'll look at an example and that will make more sense. Okay? The mode that is the value that occurs most often. Okay. When you have more than one mode, we call, so if you have two modes, then your data is said to be bimodal. All right. Let's quickly look at some of the advantages and disadvantages of the different mean, medians, and modes. So the mean, the good thing about the mean is that it is very easy to calculate, and we use every single value. So every value is used. But because of this, because we're using every single value, it means that your mean is sometimes not an accurate reflection because it is influenced by outliers. Now, what is an outlier? An outlier is really just a value that's either very, very small in your data set or very, very large. So for example, if you think about a class test, okay, there'll be some people getting maybe 20%, but then there's other people getting 90% in the same test. So those we would call outliers. And then everyone else is somewhere in between those. Okay, so your mean is affected quite significantly by rather small values and rather big values. Okay, so that's the disadvantage about the mean. The median, however, is not affected by any outliers. All right, it is the middlemost value, so it's not affected by outliers because you're not going to use the smallest and the biggest value to work out the median. All right? The mode is very useful to work out the most popular value. So for example, if you were doing a survey, and we're talking about non-numerical data now, so if you were doing a survey and you wanted to know what is the most popular drink that someone drinks, you know, or what is the most popular drink in your school, okay, that's when a mode will be useful. Okay, it can be used for non-numerical, as I just said, and obviously, very, very importantly, it does not occur if there are no repetitions. So if every single one in your school likes a different product, all right, there's no repetition, so not all of you like, you know, the orange cool drink or whatever it is, then you can't use the mode. Okay, so it works better when you have, well, it only works if you have repetitions. Okay, we're going to look at the different types of data. The one you get is the quantitative data, which is really what we'll be using. And this is all the numerical data that can either be counted or measured. Okay, so your quantitative data divided into two parts. You can either count it or measure it. Okay? We call quantitative data that is obtained by counting, very, very important. If you're counting your data, we call that discrete data. And for example, if we look at the number of pupils in the school bus in the morning, so anything that has a discrete value, so an individual number, that you would call quantitative data. Sorry, not quantitative, you'll call that discrete data, and it falls under the subheading of quantitative data. All right, another way we can we define quantitative data is by measuring. All right, and then we call that continuous data. Okay, so for example, if you look at measuring the height of someone, it's something like maybe 1,56 meters. Okay, so you can see that 5,6 is a decimal point, it's not a discrete value, so therefore you have to measure to get that height, so that will be a continuous kind of data. So just to recap, quantitative data is divided into two parts. It's either going to be discrete, which means you can actually count it. So for example, the number of people in your class, all right? And then you also get continuous data, which you actually have to measure. Okay, so for example, if you're looking at the height of people in your school. Okay. All right, so those are the terminologies that you guys need to remember for today's lesson. Okay, and we're going to quickly go on to our first example. So here we're given the following results for a class test, and the test is out of 20 marks. Okay, they want us to calculate the measures of central tendency, the mode, the mean, and the median. Okay guys, so what's very, very important when you have, this is discrete data. As you can see, everything has individual or discrete numbers. Okay, it's integer values. When you have a set of discrete data and you need to work out your measures of central tendency, You need to make sure that your data is ordered. Ordered means you're going from smallest to biggest. So you're going in ascending order. Okay. So what we've done here is we've got a set of data that's ordered. It's got 10, 11, 11, 12, 12, 12, 14, 16, 17, 18, 19, 20, so on. So first question, let's find the mode. All right. Now remember, your mode, that's the value that occurs most frequently. So it's most often. Okay, so now when you've got a nice ordered set of data, you can simply look at the data and then see what your mode is going to be. Now, if we look at our data, we see that we've got 3 sets of 12, or 3 counts of 12. 3 people got marks of 12 out of 20. And then we also see 3 people got marks out of 14. If we go further into the data, we see that 2 people got 18 out of 20. And 2 people got 11 out of 20. Okay, so the mode is the value that occurs most often, but here you see you're sitting with 2 sets of values that occur most often. And that's 12 out of 20 and 14 out of 20. So when there's 2 things that occur, or 2 sets of numbers that occur the same number of times, then your data is said to be bimodal. And your modes are then 12 and 14. So there's 2 values that occur most often, and those values are 12 and 14. Okay, let's look at the mean. Right, so remember, for the mean, you use the symbol x bar to represent your mean, and you find it by adding all of your values together and then dividing by the total. Okay, so all our numbers together, so we've got 10 plus, we've got 2 sets of 11, so I'm going to say 2 times 11 plus, we've got 3 sets of 12, so it's 3 times 12 plus, we then have 3 sets of 14, so we add that up 3 times. Then we've got a 16, and we've got 17, and I'm just going to continue it underneath it, plus 18, we see there's 2 sets of that, plus 19, and then someone who was very, very smart got 20 out of 20 for that test. And we divide the whole thing by the total number of pupils in the class, which was 15. Okay, and that's going to give us our mean, or the average for the test. So it's a way that you can work out if you're doing quite well or if you're not doing too well in your test. Compare your mark to the average. Okay, so let's do that. So we've got 10 plus 2 times 11 plus 3 times 12 plus 3 times 14 plus 16 plus 17 plus 2 lots of 18 plus 19, and then plus 20. We get that total value. We divide that by 15, and we see that our average is 14,5. Okay, so 14.5 was the average mark for that test. Okay, obviously if you did better than 14.5, you were above average in this test. Okay, next I ask you to work out the median. Now remember, the median, all right, let's just get that back up there. The median is the middlemost value. So it divides your data into 2 equal halves. So what sits right in the middle? In this case, because we're dealing with 15 numbers, okay? Now if you've got 15 numbers, it means that there will be an exact midpoint. All we do is we count how many numbers to the left, how many numbers to the right. So for example, we go 1, 2, 3, 4, 5, 6, 7. All right, and then we want something, we will need to have a middlemost number, so there needs to be 7 numbers after that. 1, 2, 3, 4, 5, 6, 7. So there we go. We divided the data into 2 equal halves. All right. And so our median sits right in between those two equal halves. All right, so therefore your median that divided your set into two halves, your median was 14. Okay, all right, guys, so that's just a straightforward example of application of measures of central tendency when we're dealing with discrete data. You obviously need to know the definitions of each of these, mean, median, mode. You need to know it in your head. You're not going to be given those definitions, so you need to understand how and when you should apply them. And I hope that you've all been following. I know that this question was actually one of the questions in your curio, so hopefully you all have this answer, and if you didn't, you now understand. I think it's about time we take a break.
So true, Natasha. As we're about to take that break, you're reminding me of words that Mr. George Bernard Shaw once said. He said, it is a mark of a truly intelligent person to be moved by statistics. So if statistics move you, that is a good sign and a marker that you are truly intelligent. But otherwise, intelligent mindsetters, we'll see you after the break. Welcome back, Mindsetters. Hope you are all chilled up, relaxed, and having your cell phones next to you, calculators, and of course your notes on hand. If you don't have your notes, make sure that you visit our Facebook page for the link. Otherwise, go to learnextra.co.za/live. And welcome to all the Mindsetters that have joined us up here, Morgan Makatini, Litwanelo, and Lithonon. I can see you guys on Facebook. And let's keep chatting and help other Mindsetters, because you guys seem to be getting the concept, and they are saying, Natasha, this is easy so far.
All right, well, that's very, very good to hear, Avram. So we're going to continue then. Before the break, we were looking at finding measures of central tendency for discrete data. We're going to continue with measures of central tendency, but now we're going to look at continuous data. Remember the difference. Discrete data, you can actually count it. It's just a number of things that have been counted, but with continuous data, you've measured it. Okay. In fact, I have actually said this wrong. We're not looking at continuous data. In this case, we're looking at grouped data. Now, what happens with grouped data, and this brings us on to what we're going to look at now, is that whatever sets of data you had have now been ordered, and they have been paired and grouped into a frequency table. Now, remember, a frequency table is set up so that you get the frequencies on one side of the table, and then you get your inequalities or your intervals on the other side of the table. So if you have a look at your table now, we'll see in question 2, we are given that the mass in kilograms of 16 bodybuilders is shown. So in fact, if we're talking about mass, it is in fact continuous data, because remember, if you're measuring your weight, you can be, for example, 50,2 kg. So therefore you are measuring, so therefore we're looking at mass. It is continuous data. It's continuous data that has been grouped into a frequency table. Okay, in your frequency table, the one side of the table will give you your interval. The other side of the table will give you your frequency. All right. But one thing you need to remember when you're dealing with a frequency table that has been grouped like this, when you're working out the mean, the median, and then later on the mode, you can only work out estimated values. Now guys, the reason for this is, remember, if you're going to take values and you're going to group them, all right, so if you look, for example, at the interval, x is where x is the weight, is less than equal to 155 kgs, but greater than 150 kgs, we've obviously lost some values in that interval. So we don't know if the person was 151,5 or if they were 151. We've lost discrete values. So that means that we're only working out an estimated mean and an estimated median. So we're saying which interval does it lie in, we look at the frequencies, and then we work out each of the different measures of central tendency. All right, so let's have a look at how we're going to do this question. Okay, so the first one, we need to work out the estimated mean. Okay, as I said, estimated because we have now grouped this table together. So, in order to work out your mean with grouped data, all right, remember this table is your frequency. If you add all these numbers up, it will give you your total frequency. So 3 plus 4 is 7, 7 plus 7 is 14, 14 plus 2 is 16. Okay, it should obviously add up to the number of bodybuilders. Okay, because they told us there were 16 bodybuilders. So that frequency will give you your total number of bodybuilders. Okay? When we're working out the mean for a grouped set of data, we need to work out, and I'm going to try and add it on this table. We need to work out, okay, and if I can't get it in here nicely, then I'm going to have to go below and try and redraw this table, but let's try. Okay, so I'm just going to include another little section to this table. Alright, and I'm going to have 2 columns here. Okay, and we'll go across each of them. So why do we need this? Because we're dealing with frequencies, we need to work out the midpoint of each of these intervals. So I'm going to call the midpoint x, and then we work out the frequency times by your midpoint. Okay, and this is how you work out your mean, your estimated mean for a group set of data. Your mean, x bar, is equal to the sum of the frequencies times the midpoint of the intervals divided by n. Okay, so you see it's slightly different from your discrete data where we just said it's the sum of all the values divided by n. Here we've got to actually take the frequency, times it by the midpoint x, and then, in fact this should be a big X, and then we divide the whole thing by n. Alright, so the first thing we need to work out is the midpoints of each of these intervals. Okay, very simple to work out the midpoints. All we do is we take our 2 end values, add them together, and then divide by 2. So we add those values together, 150 plus 155, divide by 2. 155 plus 160, divide by 2, and so on and so on and so on. Okay, that will give us the midpoint of each of those intervals. Okay, so let's call up our calculator and let's get cracking. All right. So, the first one, we've got 150 plus 155, and we're going to divide that by 2. So our first interval, our first midpoint is 152,5. So that's what we put in the midpoint column. Okay, so 152,5 is our first midpoint. We then go to the next one. It's 155 plus 160. And yes, guys, you do have to show out all of these workings. You get marks for this. So just working it on your calculator, because your calculator obviously can work out the midpoints and all of that for you, but you need to show all of your workings. So this one was 157,5. Okay. The next one, we've got 160 plus 165 divided by 2. And here you've got 162,5. And then in the last one, we're going to take 165, add 170, and then divide that by 2. So we get 167,5. Alright, once you've got all of the midpoints, you now need to times the frequency by that midpoint, and then we're going to add that all together. Right. So the first, we'll start from the bottom and go up. So we've got 167,5, and our frequency for that last midpoint, our frequency was 2. So we're going to say 167,5 times 2, and we get 335. Okay, so we're going up, remember. The next frequency is 7, so we're going to say 7 times 162.5, and that gives us 1,137,5. So it's 1137,5. Right, and you just go up the table doing exactly the same thing for each of them. The next one, it was 157,5 times by 4. and that gives us 630. And then the first one, 152,5, and we times that by 3. We get an answer of 457,5. Alright, once you've got this column, your frequency times your midpoint, you now need to add all of these values together and divide it by n to work out your median. Okay, so it's going to be 457,5 plus 630 plus 1137.5 plus 335 divided by the total, which was 16. Okay. Right, let's do that. Okay, so it's 457.5 plus 630 plus 1137.5 plus, what's the last one we've got there? 335. Right, get that total, divide that by 16. So 160, see, we've already got an equal sign. 160 is the average weight of all of these bodybuilders. Okay, so the weight started at 150 and went all the way to 170, but your average weight is 160 kilograms. The next thing we need to work out is the estimated median. Now remember, the median is the middlemost values. So we've got 16 bodybuilders that we are looking at. So we know that the middle value is going to lie somewhere on the 8th data set, at the 8th data point. How did I get that? I simply took 16 and divided by 2. So it's going to lie somewhere between the value of 8 and 9. Okay, the 8th and 9th value. So what we would do is we simply look, we add our frequencies, and we see where the 8th value would lie. Which interval will it lie in? So 3 plus 4 will give me 7. So over there I'm already up to 7. And then 7 plus 7 will give me 14. Okay, so all I'm doing here is I'm adding the frequencies. All right. And so in interval 2, so that's between 155 and 160, we are only up to 7 bodybuilders. So therefore we know that the 8th one must fall in the very next interval. Okay, because obviously if 7 ends up to 160 kilos, then 8 must fall into the next interval. So therefore our estimated mean is going to be in the interval 160 to 165. Okay, so that's going to be our estimated median. It's going to lie in that interval 160 to 165, and all we do is we're going to say, well, if we're looking for the 8th value, we're starting from 160 to 165, so therefore the estimated median is going to be in that interval. Okay, so it's in the interval 160 to 165. All right. Okay, then the next one says, where is the modal interval? Now remember, your modal interval is where the most amount, or where you get the most repetitions. Now if you look at your frequencies, we've got 3, 4, and 7. So we've got most of our repetitions in this interval, in the 3rd interval. So therefore our modal interval is going to be 160 to 165. So our modal interval is x is less than equal to 165, but greater than 160. Okay, so that's our modal interval. Okay, and remember, because we're dealing with grouped data and we're dealing with continuous data in this case, we can't tell exactly what that mode is going to be. We just know that it's going to be in the interval, in the 3rd interval between 160 and 165. And we know that because we see that the most number of values occur in the 3rd interval, because we've got 7 values in that interval. All right. Okay, guys, I'm going to cross over to Abram and see if you have any questions.
So far, there are no questions over the page. However, I have some mindsetters who are saying they're enjoying the lesson, and the part is just so easy for them. I've given them the question and also the keyword for the Curio. It is M10. Go over Curio and make sure, mindsetters, that you answer those questions. But for now, I think we should take an ad break. What do you think, Natasha?
I think that's a good idea.
All right. On that note, mindsetters, I have some exciting news that I need to tell you. Mindset is looking to hire someone, and we need your help. If you know of anyone who could be interested in doing grade 10 to grade 12 CAPS aligned content development, review, and video presentation, make sure that you visit mindset.co.za/learn and /jobs. The closing date, it is the 26th of August. So I'll keep the information updated on our Facebook page so that you could find out more on where you could go to help other people also. But for now, see you after the break. Welcome back, mindsetters. Now taking a look over Facebook. Remember, you can like our page and tell your friends to like our page if you have liked the page. It is facebook.com/learn extra with an XTRA without any E. Now, let me take a question from our Facebook page and let Natasha help. Libya Lisohonono Jomo. He says, why do we divide the mass by 2?
All right. Okay, guys, so remember here we're dealing with grouped data. Okay, so it's not the same as where we just had our discrete values and we could just add all the values together and divide by the total number to work out our mean. Here we were working with the estimated mean because we were working with the midpoint of each of our class intervals. So the reason we had to divide by 2 is because if you look at an interval, for example, the first one, we're looking at weights between 150 and 155. Now, you don't know what values are in between here. You don't know if the weight was 151 or 152. You don't know what the exact values are. So to work out the estimated mean, you've got to add the 2 outer values. So you add your endpoints, the 150 and the 155, and you then divide by 2. So you're getting an average of those intervals that you can then use. So that's the X column here. You can then use that average to help you to work out your mean. Okay, and that's because we don't know what exact values fall in that interval. Okay. Another thing that I think I need to clarify with you guys is the difference between a modal interval, which is what we were asked for in this question, and a mode. Now remember, when we're dealing with mode in discrete data, we're talking about the number that occurs the most often. All right? Now, when we're looking at a modal interval, we're looking at an interval where the most amount of data is found. Okay, so there's a distinct difference, right? We're looking at an interval where the most amount of data is found, and we see that in our table, all right, if you look at the first interval, we've only got 3 sets of data coming through from there. In the second interval, we've got 4 sets of data. In the third interval, we've got 7 sets of data. So therefore, our modal interval was X is between 165 and 160. All right. Okay, so remember that. Okay, there's a big difference between modal interval and working out your exact mode which occurs the most often. Okay. All right. Hopefully all of that has been cleared up and clarified. All right. So let's move on to the next section very quickly. And that is the section on measures of dispersion. So remember, so far we've been looking at measures of central tendency, and that was our mean, median, and mode. Now, what is a measure of dispersion? Now, what we use that for is to get a better understanding of how the data are distributed around the measures of central tendency. Okay, so we need to work out how spread out the data is. Is it all grouped together, like nice and neatly, like, for example, if you're looking at class marks, is everyone getting around 50%? Or are there some people getting 80s and 70s and then the rest of the class are way down getting 20s? You know, it doesn't make sense then. So we've got to look at the data and see how spread out they are around your measures of central tendency. Okay. So we need to use measures of spread, and we call these measures of dispersion. Okay. The measures of dispersion will tell us if the data, as I said before, It'll tell us if they're grouped together or if they are spread out. Okay, now some of the common terminology that you will use. Okay, you will come across something called the range. And your range is simply the difference between the largest value in your set of data and the smallest value. All right? This cannot, very importantly guys, it cannot be calculated when your data is grouped in frequency tables. So for example, in the last example we looked at the mass of bodybuilders, we don't know what the maximum mass was, because remember this was all grouped together. Okay, so we used intervals that worked nicely. It doesn't mean that the last person had an exact weight of whatever it was, 165 kgs or 170 kgs. So we don't know what the maximum value is, we don't know what the minimum value was, so therefore we cannot work out the range from a frequency table. All right? The range is also affected by outliers, so if you've got some very big value, some very small value, that's going to distort your range. Okay? Another measure of dispersion that we use is called quartiles. All right. Now, how this all links in is, remember, your median divides your data. Remember, if it's an ordered set of data, your median is the middlemost value. Okay, and what it does is it divides the set of data into two equal parts. So two equal parts, all right? Now what that means is about 1/2 of the data is less than the median, and 1/2 of the data is greater than the median. Okay. It is, however, possible to further divide this data into 4 equal parts. So remember, your median's dividing it into 2 equal parts. We can now divide it into 4 equal parts using the quartiles. All right? The symbol we use to represent quartiles, Q1. Okay, Q1, that's also our, we call it Q25, which is our lower quartile, which means 25% of your data. So this is Q1. And it tells you that this is the 25% mark, basically. So it tells you that 25% of your data is less than whatever your lower quartile value is there. All right. You then get Q2, which is the same as your median. Okay. And then you get an upper quartile. Now the upper quartile is the value. All right, our number line's looking a bit off, but the biggest value is the one that's right at the end here. Okay, so that's our biggest value. And then our smallest one was obviously on the other end. And then about 75% of the way up, so we call this one Q3. Okay, and Q3 is the upper quartile. All right, and it tells you that 75% of your data is less than that specific number. Okay, so when you're working out your quartiles, you'll get some number as your Q3 or your 75th quartile, and 75% of data will be less than or equal to whatever value we've worked out for Q3. All right, that will make more sense when we're looking at an example. Okay, so let's just go over it again, because this number line is, something's out of place on this number line. You have your median, which divides your set of data into 2 equal pieces, right? Then you get the lower portion and you get the upper portion, all right? Within the lower portion of numbers, you can do a further subdivision, okay, into 25%. So you can say 25%, which is your lower quartile, of whatever you're looking at lies below this certain value. Okay, so you take your lower half, divide that in half, all right? Then when you look at your upper quartile, you're basically taking the upper half of your set of data and you're dividing that into a further a half. So then you can say 75% of data lies below a specific value. All right, but it's going to make more sense when we look at an example. All right, so we are given that these are the marks in percentage form for a group of learners. Okay, We are then asked if the data is discrete or continuous. Now remember, with discrete data can be counted, and continuous data is measured. So therefore here we can count, so therefore the data is discrete. Okay, first part answered, easy. Right, let's look at the next part. They say, find the median, the lower and upper quartiles, and the interquartile range, which is a term that we haven't seen yet, but I will discuss that when we get to it. Guys, before you even attempt any of part B, you need to rearrange this set of data. We need to order it. Okay, so we need to take that set of data and we need to order it before we can answer the questions about the median, the lower and the upper quartiles, and the interquartile range. You have to have an ordered set of data in order to work that out. So what I've done in the break is I've already reordered that set of data. Because remember here we're dealing with the marks in percentage form for a group of learners. It's quite a lot of marks there, so I've just reordered it. Okay, and this is what we get. Okay. Let's have a look at how many values we are looking at here. So I've reordered it from smallest to biggest. Okay, so we're starting at 55, and someone got 100%, so that's our highest mark. Okay, let's see how many numbers we've got in this set of data. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Guys, I wanted to show you an example like this to show you that they're not always going to tell you, look, there's 34 learners in the class. How are you going to work it out? Easy. You just count how many numbers or how many marks you've got and how much they've given you. So therefore here we're dealing with 34 learners. Okay. Now that the data is ordered, let's look at the first part of the question, right? They say, find the median. Now remember, your median is the middle most, or the middle, exactly in the middle of all the data. We're dealing with an even number of points. Okay, there are 34 learners. So therefore, we're not going to be able to say 34 divided by 2 is 17, and then the 17th value is going to give us our middle number. No. We are going to have a median that lies between two numbers because we have an even number of data points. Okay. So, let's count. We've got 34 altogether. 17 is a good starting point, okay, to find the middle value. So 34 divided by 2 is 17, all right? We know we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we're looking at that being the exact 17th point, all right? It's not going to be the middlemost number, and this is why. If you count everything below there, you've got 16 values. But if we count above it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You see we've got one more above that middle value of 75. So therefore, our median is going to lie between position 17 and 18. Okay, so it's going to lie in between the 17th and 18th position. Okay, so I want to find out what that middlemost value is. So I take the 75, add it to the 75, divide by 2. In this case, it's easy because we're still going to get 75. So therefore, the median is going to be 75. Okay, if there were happen to be two different values, so if it wasn't 75 and 75, you'd still do the same thing. Take the two numbers, divide by 2, and see what your middlemost value is. All right, so 75 is the median. Now what that means is that half of the values lie below 75 and the other half lie above 75. Okay. They then say work out the lower quartile. So remember, the lower quartile is Q1. Okay. In order to work out the lower quartile, you take your lower half of numbers and you then work out a further middle point. Okay. So let's use a different color here to show you what we're doing. So we're going to look at just this part of the data. So we take the lower half of data and we once again find the middle of that lower bit. Okay, so it's just that part in blue. Okay, so there we know that there's 16 numbers there. All right. We then need to divide that by 2 to give us an idea of where our middle point is going to be. All right, so 16 divided by 2 is 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's my 8th place. Okay, and then we know that because we're dealing with an even number of data, our middlemost point is going to lie between position 8 and position 9. So therefore we take 65, we add it to 65 and divide by 2. So we get that the lower half of the data, the middle of that, is going to be 65. Okay, how did I get it? I simply looked at what the middle point is in the lower half of data. All right. And they then asked us for the upper quartile, so we do exactly the same thing now with the upper set of values. Okay, so we're looking from here to there. Okay, you take that set of values, again there's 16 there, and we're going to, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It has to be 16. Divide by 2, exactly the same thing. It's in the 8th between position 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8. That's position 8. That's position 9. Take those two values, add them, divide by 2, and you get your upper quartile is 85. Okay, guys, before we go into the rest part of it, I just want to explain to you what these numbers tell you. So we've worked out the lower quartile is 65, all right? What that means is that 25% of all learners got a mark less than 65%, okay? We worked out the upper quartile is 85, all right? What that means, upper quartile, 75% of learners got a mark that was less than 85%. That's what those two values are telling you. Okay. All right. Now, if you look at the next part of the question, they said work out the interquartile range. The interquartile range is basically the difference between your upper quartile and your lower quartile. So your interquartile range, which is abbreviated as IQR, it's just your Q3 minus your Q1, all right? And that's just going to be 85 minus 65. So that's going to be a difference of 20. So your interquartile range is 20. We've got our upper quartile, our lower quartiles. We've got our medians, and this is how you can use your ordered set of data to work out all of those values. I think that we are running out of time, so I don't want to go on to another question until I cross over to you, Abraham.
All right, quickly. So, how did you get on question 2 your estimated median? Quickly.
Our estimated median on this one.
On question 2. Because a lot of our mind sitters seem to be confused there.
Question 2. All right, let's quickly find it. So this was the mass in kilograms of 16 bodybuilders. And question 2, let's quickly go down there. All right, so they said calculate the estimated median. Is that the one we're looking at?
Yes.
Hey? All right, so what did I get? I don't actually know what I wrote as an answer because I've sort of put everything everywhere, guys. So I don't know what I wrote as an answer there, but your estimated median, to work it out from your table, you're going to see, well, I'm looking with I'm working with 16 sets of data, right? So I know that the position of my estimated median is going to be between data 8 and data 9, so whatever those two values are. So your estimated median is going to lie in that position, so between the 8th value and the 9th value. And that seems to occur in the interval 160 to 165, because up to here we've got 3 plus 4 is 7, 7 plus 7 is 14. So this is the interval in which your estimated mean will occur, but it will be in position between position 8 and 9. All right. I hope that I've answered that. I think we are running out of time, so I can't explain it a little bit more. Hopefully, you guys do understand that table and how to work out its position.
Thank you so much, Natasha. Well, mindsetters, if you still have those questions, go to mindset.co.za/help desk. We'll be there to help you. Also on our Facebook, we'll try by all means to help you. That's all we have for today on Maths for Grade 10. Catch us some other time. For now, peace.
A data set. So it's the number that's exactly midway. So if I had to sort of draw a picture for you, it's the one that's exactly midway between your set of data. Okay, but in order for you to work out the mean, you need to have an ordered data set. If there's an even number of values, okay, so if you have, for example, say you have 12 values in this data set, then your median is going to be in the middle of the middle two numbers. So what that means is if you've got 12 numbers in your data set, obviously a half of 12 is 6. Okay? But when you order your data, you're not going to be able to get 6 numbers on one side and 6 numbers on the other side. You're going to have 2 central values. So what you would do is you take those 2 numbers, you add them together and divide by 2 to give you your median. But we'll look at an example and that will make more sense. Okay? The mode, that is the value that occurs most often. Okay? When you have more than one mode, we call, so if you have 2 modes, then your data is said to be bimodal. All right. Let's quickly look at some of the advantages and disadvantages of the different mean, medians, and modes. So the mean, the good thing about the mean is that it is very easy to calculate, and we use
Hello, awesome mindsetters. This is your favorite show, Learn Extra Live, with me, AB Abram, and we are having our Triple M dates back. It is our Mindsetters Maths Monday with Natasha. How are you, Natasha?
I'm very well, thanks, Abram. Thank you for asking, and it's good to see you back on a Monday.
Happy Women's Month.
Thank you, thank you.
I hope you also enjoyed your Women's Day.
I did, and it wasn't a good restful day, but it was still good.
It was a long weekend, though. I hope it was long enough for you to rest.
No, absolutely not. I think our long weekends should be much longer.
Oh, I'll ask the mindsetters about that, because to me, I felt like, you know what, it is just too much. I need to come back to work and do what I love. But otherwise, what are we doing today?
All right, well, grade 10, today we're looking at statistics. Specifically, we're going to cover measures of central tendency, and we're also going to look at measures of dispersion.
I like that. Now, let me tell you, mindsetters, we have 4 exciting things that you need to know. One is that you can chat with me over Facebook. Our Facebook page is facebook.com/learnextra. Like the page. We're currently having about 49,954 likes. So join us and be
statistics in grade 10. So what is a measure of central tendency? Well, basically, it just tells you what a typical value in a set of data is going to be. Okay, so let's formalize our definition. A measure of central tendency is a value that represents a typical item in a set of data. All right, we have different measures of central tendency. The first one we'll look at is a mean. And a mean, another word we use for mean is average. Okay, your mean or your average is equal to the sum of all the values in the data set divided by the total number of values. We also represent the mean as x bar. Okay, so you'll also see it being represented like that, and we say it's the sum of all the values in the data set divided by the total number of items. So you might come across the mean written in this way, and that's basically what it means. We're taking the sum of all the values dividing by the total number of values. Okay, so that's the first measure of central tendency. The next one we're going to look at is the median. We also represent the median with the letter M, capital M. And the median is basically the middle value of
that's 66 for us to have 50,000. And if you don't know about anything, what Mindset has to do, go over Facebook. We'll tell you what's happening even during the show. If you have any questions, feel free to go over Facebook, like us, and if you have liked us, comment and help other Mindsetters. Secondly, you can join us on Twitter, follow us at LearnExtra. And then thirdly, you can download your notes for today's show just for free on learnextra.co.za/live. And the last thing that you need to do, we are on Curio, whereby you can visit Curio on curio.co.za or via your Mixit, and then your code for today's show is M10. Take the assessment and let's see if you understand anything, because at the end, Natasha will be helping you on some of the questions that are on Curio that are giving you some troubles. But for now, enough about talking. Natasha, take it away.
All right, thank you, Abram. All right, guys, so as I said in the beginning, we're looking at measures of central tendency, and we're looking at measures of dispersion within statistics. Like Abram was mentioning about the Curio question, one of those questions we will be looking at in today's lesson. So if you have any problems, obviously you can follow through with us during the lesson and let us know where you struggled and where you still need a little bit more help. Okay, so first we're going to go over the definition of what is a measure of central tendency. I'm sure that most of you would have come across this term by now during every single value. So every value is used. But because of this, because we're using every single value, it means that your mean is sometimes not an accurate reflection because it is influenced by outliers. Now, what is an outlier? An outlier is really just a value that's either very, very small in your data set or very, very large. So for example, if you think about a class test, okay, there'll be some people getting maybe 20%, but then there's other people getting 90% in the same test. So those we would call outliers. And then everyone else is somewhere in between those. Okay, so your mean is affected quite significantly by rather small values and rather big values. Okay, so that's the disadvantage about the mean. The median, however, is not affected by any outliers. All right, it is the middlemost value, so it's not affected by outliers because you're not going to use the smallest and the biggest value to work out the median. All right? The mode is very useful to work out the most popular value. So for example, if you were doing a survey, and we're talking about non-numerical data now, so if you were doing a survey and you wanted to know what is the most popular drink that someone drinks, you know, what is the most